Okay, so this video is to help people struggling with percentage mass calculations. Now, to be able to do this, you need to know how to use basic chemical formulae and to calculate an MR. If you can't do either of those things, you need to go back and sort that out first, because none of this will make any sense otherwise. Okay, so let's start with percentages in principle, basic maths. What percentage is x of y? So we have two things. We want to know what percentage one is of the other. The maths is quite straightforward. It's x divided by y times 100 gives us the answer. So for instance, what percentage is 20 of 40? 20 divided by 40 times 100 is 50. Simple as that. So now, what's it like when we apply this to chemistry? So what they're going to ask you to do is work out what percentage element X is of compound Y, and we're not talking in terms of how many atoms there are, we're talking about how much it weighs. It's a percentage mass. So to do this, you need to find the formula for the compound, the AR for the element, and the MR of the compound. You will generally be given all of these in modern GCSE chemistry papers, but even if they didn't, as long as they've given you the formula for the compound, that's really all you need, because the AR can be found from the periodic table and the MR can be calculated from the periodic table. So here's our first example. Ammonia is NH3. What percentage of ammonia is nitrogen? So the MRs are given to us here. We have 17 for the ammonia, 14 for the nitrogen, and 1 for the hydrogen. They always give you the full set, even though we won't actually use all of them. So what do? We want to know what percentage the nitrogen is of the ammonia. So it's N divided by NH3 times 100. If we put the numbers in, that's 14 divided by 17 times 100, 82.4%. Now it's really critical that you get the rounding of any percentages you give right. If you gave this as 82%, you'd be correct. 82.4%, you'd be correct. 83%, you're out, and you're going to lose a mark for that, possibly more than one. Okay, a harder question. Aluminium oxide is Al2O3. What percentage of this compound is aluminium? Now they've given us the MR of the aluminium oxide and the weights of the aluminium and the oxygen. Now this initially looks exactly the same as the last question, but we have a 2, and that makes a difference. Because we want to know the total aluminium, not just one of them, we need to actually do Al2 divided by Al2O3. So when we put the numbers in, we do 27 times 2, divide that by 103, and then times the whole lot by 100 to get 52.4%. That's the pretty much standard level of difficulty you're going to encounter in a GCSE chemistry paper. There is one potential one they could give you that's harder than that though. So this is probably the hardest one you could get at GCSE chemistry. Ammonium nitrate is NH4NO3. What percentage of this compound is nitrogen? Now the problem with this one is that there are two nitrogens in two different places. It doesn't actually matter that they're at different places in the molecule, they both count. So when we do the maths for this one, it's N2 divided by NH4NO3 times 100. Put the numbers in, 14 times 2 divided by 80 times 100, 35%. That's probably the hardest one you would be likely to get at GCSE level chemistry. Now if you can do this and the preceding processes, you can do all of the maths for a foundation chemistry paper. There are some harder techniques, notably the empirical formula and the reacting maths question. We'll leave those for a later video, but if you are going to do higher tier chemistry, it's really important that you can attempt both of those questions, because they're often worth 4 marks. That could be anything from half to 3/4 of a grade.